Okay, this video is on Ka and Kb. So just like we did Keq, and remember that K means constant, right? And you see that word or that letter used in physics and math and also chemistry. And the Keq is for the equilibrium constant, right? And so Ka is the constant of an acid, and Kb, as you can guess, is the constant for a base. So if you look at your table of acids and bases, what you'll see is that on the very last column there is a column just for Ka values, and you should see like the very first 6 acids, right, which are very strong acids. All they will actually say is they'll say that they have a very large Ka value, and then there'll actually be numbers for the ones below it. What you should see is that the numbers will decrease as you go down the list. So the stronger the acid, the bigger the Ka value. So the stronger the acid, the bigger the Ka value. The other thing you need to know about Ka and Kb is that if you add Ka and you add Kb together, you get that Kw. Let's see, do you remember what Kw is for? The W is for water. Remember that the Kw is actually equal to 1 times 10 to the negative 14, right? This number is actually in our data booklet. It's like on page 3, and it's actually like in miscellaneous data. Okay, so the Ka for a very strong acid doesn't actually have a number. It's because it is very strong acid. So very strong acids do not have a number listed because they almost 100% dissociate. So they break apart. Okay, so let's try a couple. So one of the questions might be to write out the dissociation equation for a weak acid with the formula HA and then write out the Ka expression for this weak acid. So HA is just not an acid that you're going to find on the table of acids and bases first off. So HA is just any acid. That's just supposed to represent any acid. So dissociating in water, so we're going to write with water. Okay, remember that if this is the acid, it has to donate its hydrogen, right? So it becomes A negative. And that if this is the base, remember that it has to accept a hydrogen, so it becomes H3O. So remember that this is the base, this is its conjugate acid, this is the acid, this is its conjugate base. Okay, so here is the first part of the question, is to write out the equation for it, or the dissociation equation. And now just like we did for KEQ, you write out the products on the top and the reactants on the bottom. Notice again, just like the KEQ, we don't include things that are liquid or solid, right? Because their concentration is constant. Okay, so this is an example of one kind of Ka question. So the question says, calculate the pH of 0.1 moles per liter solution of nitrous acid. Assume there is no change in the concentration of the acid. So the very first thing that you have to do is write out the dissociation. So this is like the first step in all of the Kas, is write out the dissociation equation. So HNO2 plus water goes to being, so again, this is the acid, right? So you should be able to do it without your table, but you can look at your table, right? Go find HNO2, go straight across from it, see what it becomes when it donates its hydrogen. It is NO2 negative. Okay, then water is the base, so it accepts a proton, so it becomes H3O. Okay, then we need to write out the KEQ, or write out the expression. So write out expression. Okay, now remember that the question is asking me to figure out the pH, right? So if I have to figure out pH, let's think about like what do I need to do pH, right? I need the negative log of the H3O concentration. So really what I'm looking for is, they gave me the concentration of this, right? I could find this on the data table. So that means, could I figure out this one? Could I figure out this one? So what I'm going to do is I'm going to manipulate the formula so that I have my knowns on one side, which are this one, and I have my unknowns on the other side. So that would look like this. So I would have Ka times HNO2 equals H3O positive times NO2 negative. Okay, because I have these two here, that means that really these are like having x squared, remember? And so therefore that this is square rooted, like so. Okay, now I'm going to go to my data table and I'm going to look up nitrous acid, and then I'm going to go all the way across to the edge, and I'm going to find out that the Ka value for nitrous acid is 5.6 times 10 to the negative 3. They told me I started with this for the concentration of it. Okay, I'm going to plug this into my calculator. And I'm going to plug this into my calculator. Hold on a second. Okay, so when I plug it into my calculator, I get this number. That's a 191. So this equals this concentration. Okay, now, it would be nice if I was done the question now, right? But I actually have to put this into here. to figure out the pH. So I'm going to do the pH at the negative log of, and I'm just going to write 0.0236, and I'm going to write dot 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 to represent the rest of that. So now I'm going to do the negative log of that number. Okay, so now my calculator says this, dot 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 dot, goes on, okay? But I started with 0.10, so that's 2 sig figs. So that means that I would write 1.63 as my pH, because remember that the numbers only after the decimal place count as sig figs in pH and POH. Okay, let's try another Ka question. Okay, so this is another kind of questions where it says calculate the Ka value for a solution which is initially 0.1 moles per liter of methanoic acid with a pH of 2.38. So this time we're actually starting with a pH equals 2.38. Okay, so again, first thing that you should do is write out the dissociation equation. So we have to figure out what methanoic acid is first, so we could find that on the table of acids and bases. And then we're going to add water to it. Okay, the acid is going to lose a hydrogen or donate a hydrogen, so it becomes this. The base is going to accept a hydrogen, so it becomes this. Okay, now we have to write out the expression. My pen must be dying. Write out an expression, so we're going to write Ka like that. Okay, now this time we actually know the pH, so think about what that's telling you, right? That's actually telling us that we could figure out the hydronium concentration from that one, right? What would we do with that? Well, that, and this is actually saying we're going to pretend like we don't know what methanoic's Ka value is, or we're going to see if it's close to what we think it should be on the table. But, so we're trying to figure out what this is this time. So what we're going to do with this is we're actually going to plug in 10, maybe. We're going to plug in 10 to the negative 2.38 on our calculators. And that gives me this number. Okay, that means that this is the number that goes here, but it's also the number that goes here, because remember that if they're to the same coefficient and they're on the same side, that means they would have exactly the same number of moles, therefore the same concentration too. So we'll put that number in there, and I'm just going to write 6 and then dot 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 for the rest of it, and then now this one, they told us it started off as this, but it's now like almost like an ice table where it's actually changed, and it will change by this amount, right? So it will change by this amount. So we're going to subtract that amount. And then we should get the Ka value. Two sig figs, so 1.18 times 10 to the negative 4. Oh, and Ka has no value, or no unit, sorry. So this is our answer. Okay, let's try another one. Last one. What's the other one I can think of? Okay, so the other one that we should try is one where we actually have like a mass and a volume and then calculate like pH or Ka. So I'll write one out first so you don't have to listen to me writing it out. Pause it for a second. Okay, so this is another one where it says calculate the pH. So we're going to try and figure out the pH. And we have acetic acid. So again, first thing that we're going to write is the dissociation equation. So acetic acid looks like this with water. And it loses a hydrogen to become this. And the water gains a hydrogen to become that. This is aqueous, that's aqueous. And then we're going to write out the expression. So the Ka is equal to the CH3COO negative, H3O over CHCOOH. Okay, because it's actually asking me to figure out pH, I really need this one. And it's telling me acetic acid. So it's telling me the mass and stuff of this one. This one. So this one is going to be a known. This one I can find from the table, right? So that means that these two are going to be unknown. So that means I have to manipulate the formula so that I have Ka times this, square rooted will give me the concentration of this, but it will also give me the concentration of this. So either or. Okay, when I look up the value of Ka for acetic acid, let me find it. It's 1.8 times 10 to the negative 5. Okay, now here, the concentration of acetic acid, we're actually going to have to figure that out, right? So concentration equals N over V. They didn't give me N, so I'm going to have to substitute M over M. So really, concentration is going to be M over M divided by V. So we're going to take the mass. So now we need the molar mass. That would be 2 carbons. Is it 2 carbons, 2 oxygens, and 4 hydrogens? So 2 carbons, that's 12.01 times 2. 4 hydrogens, that's 4 times 1.01. And 2 oxygens, 2 times 16. So when I do that, I get 60.06 grams per mole. And then I'm going to divide that by 2.50 liters. Make sure when you do this on your calculator, you do this first, push enter, and then divide by that. Okay, so now we figured out the concentration to be 0.0, when I do this on my calculator, 666,000. 666. That's quite the number, hey? Moles per liter. Okay, so we're going to put that number over here. 0.666. And I'm just going to write dot, dot, dot. And we're going to square root that number now. And I get 0.0 Just checking my calculator. Can't read it anymore. 4, 8, 9, 7, 8. Okay, so this is this. So that means now I could actually figure out the pH, right? By doing the negative log of okay, so let's try that. So negative log of 0.00109. And how many sig figs do I want to have? I gotta go back and look. Looks like 3, right? Because there's 3 here, there's 3 there, so 3. Okay, so it should be 2.962573502 is what my calculator reads. So we're going to write 2.963 is my pH. So it looks like that. Great, so that's all there is. So should be able to do Ka and Kb now.